Alright guys, this is Lisa Knight. Let me talk a little bit about the juggling lab. So in this lab, I'm going to be doing two things. First, you're going to verify that when the juggling ball is in free fall, that means that the hand isn't touching the ball and it's just rising and falling, that its acceleration is the acceleration of gravity. And then you're also going to look at the change in momentum and the impulse acting on the ball when it changes direction. Alright, so the first thing you're going to do is you're going to be given instructions in the activity to do the video analysis. To do the video analysis, the first thing that you'll want to do is you'll want to set the scale in the video. So you'll click on the Set Scale button and you will point and drag along the meter stick and make sure that the 1 meter is set for the number of pixels. And then, as described in the lab, you're going to advance 1 frame. There's actually 32 or 33 frames in the video. And you're going to track the motion of this third ball here, the one in the bottom of the video. And you're going to click on Track or Add Point. And you're going to pick one area of the ball to track. So I'm going to pick the center of the ball. And I'm going to basically track it for each frame. For all 32 frames. And I want to try to be really careful to always track that same point. And this literally takes just a few seconds to do. It's not bad at all. Remember that when the hand is touching the ball is not in free fall. But when the ball leaves the hand, which happens at about the 15th frame, and notice that the frames are right here at the listed at the upper left hand corner of the video. Now the ball is only being pulled down by gravity, so that means its acceleration should be negative 9.8 meters per second squared. When the hand is touching the ball, the acceleration will not be negative 9.8, and it won't be a constant acceleration either because the force is varying on the ball. It's not a constant force that's being applied to it. And I'm just going to keep adding points until I get to the 32nd frame. And you'll notice that along the right hand side we have two graphs. We have the acceleration graph, right? We have the acceleration graph, and notice that the acceleration kind of hovers around negative 10, right? Close to negative 9.8 in that area that I talked about where it's in free fall. And if you click on the Examine button here, okay, and at the Examine button, and you fast forward until you're at the 15th frame up in the left hand corner of the video, and you highlight to the end of the video, that area is all free fall. Okay, that ball is in free fall, and you notice that we stay in the same about the same acceleration. Sorry about that. I'm trying to turn off my notifications. Somewhere I have lost my graph. Let me just find it here. There we go. There we go. All right. In your lab, you will be asked to highlight frames 15 through 33 and to do a curve analysis. So if you remember, this object is in free fall, which means that it is accelerating at a constant rate, which means that this position graph should be a parabola or a quadratic. So when I go to the curve fit button, I should be doing a quadratic fit. And to tell whether, when I click on try fit, this RMSE should be very close to 0, and it is. The correlation should be very close to 1, and it is. If you look at this, remember that this correlates to our kinematics equation. The height equals 1/2 of gravity times time squared plus VIT plus the initial height. So our coefficient A here should be about half of gravity, and this is -5, which is close to half of -9.8, barring some error in the way that I did my video analysis. You guys, I've done this before and gotten very close to -4.9, so you guys can too if you're a little more careful than I was. So this is a very good way for you to find your gravity value, which you're asked to find your acceleration in the y direction, which would be the value of gravity, or close to it. So that's one thing that you're going to do. The next thing that you're going to do is you're going to find the change of momentum for the catch and the throw process. So to do that, you're going to go back to your data chart and you're going to find the velocity at frame 3 and the velocity at frame 13. And they tell you that the mass of the ball is 105 grams. So to find the velocity at frame 3, you're simply going to go to 3, and the velocity at frame 3 in this case is -1.900, and my mass was 105 grams. I need to convert that to kilograms, so it's 0.105 kilograms. To find my momentum to start with at frame 3, my momentum or my initial momentum will simply be my mass in kilograms times -1.900 meters per second. Then at frame 13, I'll just scroll down and find my velocity at frame 13 and multiply my mass by that to find my momentum at frame 13, or my final momentum. I'll be asked to find my change in momentum, which is the final minus the initial, so be careful with your positives and negatives and subtracting there. And then I will be asked to tell me also report the impulse. Remember, the impulse is equal to the change in momentum. So whatever my change in momentum value is what my impulse is. The units for both momentum and impulse is a kilogram times a meter per second. And then finally, you'll be drawing some vector diagrams. You'll be drawing a picture of the gravitational force acting on the ball, and then you'll draw a picture of the juggler's force acting on the ball, and then you'll draw them both on the ball at the same time. And then you'll answer some questions about that. So, with that in mind, I think you can do this lab. If you have any questions, please ask me.